Hello everyone, welcome you all to Easy Max Learning YouTube channel, and today we are going to continue with polynomials, and the topics that will be discussed today are the factor theorem and remainder theorem, and some problems related to these two theorems will be solved here. Let's see the general form of polynomial. A polynomial with a single variable with degree n is always represented by the form p of x equals an xn an plus an minus 1 x power n minus 1, and it progresses that way until it stops at the constant. And this is the general form, and based on the pattern this can vary very much. Here an minus n, they are all the coefficients, and all these numbers should be real. And this is a variable, the single variable polynomial. The variable is x, and variable is anything, the value can be anything, it is not something determined. And a naught, an, all these are all the constant coefficients that are available here. The general form polynomial in terms of the variable x, so we represent it as p of x. Always the highest degree of x will be the highest exponent of x will be the degree of the polynomial, and n should always be non-negative, and only it should be in from starting from 0 to infinity. It should not be with fraction, or it cannot be in negative. When it is negative, then it is no more a polynomial. So this is the general form that we already discussed in the previous video. The first is the factor theorem. The zeros or the roots of a polynomial. That is, in the polynomial, if you substitute with some number, then the entire expression becomes 0. That is, p of x will be equal to 0. When it is evaluated that way, then we call it as a factor of the polynomial. You put a number in that, and by any means, if the entire value becomes 0, then they are the factors, or in other words the roots, or the other name is zeros. They are all mean the same. So they are all the zeros or the roots of the polynomial. So in general, if for a expression x minus 1, a common expression, if you say that is a factor of polynomial f of x, only it is possible if you substitute in place of x, if you put a, that is f of a, the whole expression should be evaluated to 0. We will solve more problems related to the factor theorem, and you will understand it better. Now first I'll give you a glimpse of what the remainder theorem and factor theorem means. In remainder theorem, it is just a continuation of the factor theorem. The factor theorem, we were saying that it is x minus a becomes a factor for the polynomial if f of a is 0. In remainder, it continues here. If you are going to evaluate the expression by x minus, if you substitute in place of x, if you substitute the value, say x minus a, then for f of x you will put f of a, and whatever the remainder, whatever value that comes, that becomes the remainder of the polynomial. If it becomes 0, that means it is exactly divisible by the polynomial. When it leaves some remainder like 3, 5 like that, minus 1 like that, then it becomes a remainder. You are dividing the polynomial, which it's like a normal division. We do 10 divided by 5. The same way, 10, assuming 10 is nothing but the polynomial itself, and 5 is nothing but a factor. Say x minus 2, x minus 1 like that. When I am dividing a polynomial, whatever remainder I get, that is the remainder of the polynomial. By this factor theorem, it will be easy for us to evaluate the remainder of the polynomial. Let's solve some problems to understand these concepts better. Assuming we have a question, find the zeros of the polynomial x square minus 5x plus 6. So this is a single variable polynomial. The variable is x, and it is also it has 3 terms in it, so it is a trinomial, and it is of degree 2, which is the highest degree of x. Now the way we can find the zeros of this polynomial is, we have to look at the constant. Constant is 6 here. So if we divide the 6, 3 2s are 6, and we have to do some operation by which we have to get the middle term here. So there it is minus 5. So if I put minus 2 and minus 3 and minus 2, it becomes easy for us to evaluate. So we can split minus 5 as minus 3x and minus 2x plus 6. Right. So now we have to take the common term among these two, x square minus 3x. The common term is only x. So it is x minus 3, and minus 2, again x minus 3. So this is a common factor, x minus 3, x minus 3. So that will be written once, and the remaining whatever left with, that is x minus 2. Yeah, so these are the two factors of this polynomial. So which is not, this is what I am trying to say before. X minus a will be a factor of the polynomial if this is equal to 0, factor of polynomial p of x, when p of a will be equal to 0. So this was a general form, x minus a factor of p of x as per the factor theorem, and we have identified x minus 3 and x minus 2 as the two factors. Now for my polynomial p of x, x square minus 5x plus 6, if I am going to substitute here with the factor x minus 3, so which is x minus 3, right? So that is, if the general form is x minus a, so in place of a we have identified 3. So p of 3, if I evaluate p of 3, what happens is, wherever x is there, directly we can put 0. Sorry, wherever x is there, we can directly put 3. And when we add this, 3 square is 9 minus 15 plus 6. And this is 15 minus 15, which is 0. So p of x becomes 0 at the point p of 3. In place of x, if we evaluate as 3, then we get 0. The same way you can work out for this also. Take the other factor x minus 2. In place of x, if you substitute p of 2, there also you will again get 0. 2 square minus 5, in place of x substitute there. So it is 4 minus 10 plus 6. So again 10 minus 10 is 0. So by this we can also confirm that these two are the zeros of the polynomial. 3 and 2 are the zeros of this polynomial. Thanks for watching, and do subscribe to the channel if you find it useful.